One of the tasks that you need to become comfortable with in organic chemistry is figuring out what the final chemical formula is for a polymer. Remember, a polymer is just a large molecule composed of many smaller units called monomers. And the monomers combine together, forming a chemical bond through a process called dehydration synthesis. And once we have this final chemical formula, we can use it later on to determine some hydrogen to oxygen ratios to figure out if we're looking at a carbohydrate or a lipid. But first, we need to figure out how to calculate it. So the first one we're going to work with is something that is called a dimer, or for example, a disaccharide, something that is composed of two individual units combined together. So to calculate the final chemical formula, you're going to take the chemical formula for this first guy, and you're going to add it to the chemical formula for the second, and that will give you the chemical formula for the final molecule. But we have to remember, when we do dehydration synthesis, one of the products is water, and that water actually comes from the individual monomers. So it will have to be subtracted. So let's look at an example. I'm going to combine glucose and fructose, two monosaccharides, and form a disaccharide sucrose. So when I combine those two, I get something new. That's why it's green, plus a molecule of water. So how do we do this? We take the chemical formula for glucose, which is C6H12O6, and we add it to the chemical formula for fructose, which is also C6H12O6. Do you remember what we call molecules that have the same chemical formula, but they have different structures? Those are called isomers. So that is going to be, when we add them together, we're going to get some combination of CHO plus, of course, a molecule of water. So we add them together. We add up all the C's, we add up all the H's, we add up all the O's, and that will give us C12H24O12. And you may be tempted to think that that's the chemical formula for sucrose, but remember, the process by which two monomers combine together is called dehydration synthesis. So we still need to subtract that molecule of water. So we subtract water. The formula for water is H2O. And after we subtract that out, we get the final formula for sucrose is C12H22O11. And of course, one of the other products is one molecule of water. So let's do a more challenging one. Let's look at a polymer that is composed of 3 molecules of glucose. So we're going to follow the same procedure. We add the formula for the first molecule with the second to the third, and that will give us the final formula for the polymer. And we have to remember we're going to be involving the release of water here. So again, looking at isomers, so C6H12O6 plus another C6H12O6 plus a third C6H12O6. So the big question now is, how many molecules of water do we subtract? Very common mistake is just to subtract one molecule of water. But we have to remember, when you connect two monomers together, it releases one molecule of water. So if I'm combining 3 monomers together, there's a bond there and there's a bond there. So it's more than one molecule of water. So each bond that is formed releases a molecule of water. So I have 2 bonds, and that will give us 2 molecules of water being released. So we take the formulas, all 3 of those added together, C18H36O18 minus my water. So what's the final amount of water that is being released? Well, I have 2 molecules of water, so I have to add them up. So H4O2. So C18H36O18 minus H4O2. And again, that just came from there, okay? And my final formula is C18H32O16 plus 2 molecules of water. So the final formula for that polymer is this, okay? One more example. Now we aren't using isomers. we have 1 blue monomer and 3 green monomers, and we're going to combine them into a polymer. Now, because they're different, each has a different formula. So the 3 green plus signs actually do have the same chemical formula of C8H12O2. It's the exact same process. You add up the chemical formulas for the individual monomers and then subtract out 1 molecule of water for each bond that is being created. So let's start this out. So we have 3, so I'm just going to keep it simple, 3 of the green. So each green plus sign has the formula C8H12O2. So just multiply your 3 across, plus 1 of the blue monomers, that's C3H8O6. So my 3 multiplied across gives me C24, just, distributing that 3 across, H36O6 plus this guy, C3H8O6, gives me a total of C27H44O12. And hopefully someone's checking my math that I didn't make a mistake here. Now I have to subtract out the water. How many molecules of water? Well, 1 molecule of water for each bond that is being created to form the polymer. So there's 1, here's a second, here's a third. And hopefully by now you're starting to see a pattern. All right, so we have 3 molecules of water. So 3 distributed across, okay, would be, whoops, now I did it. So H6O3 would be for, right down here, sorry, I goofed up this thing with the water. Okay, now let's see if I move on to the next one. Oh, shoot. I don't know how to get rid of, this thingy here. So you're not going to be able to see anything. Oh, grr. All right, so we have C24H36O6, and there it goes. Okay, add them together. Where did it go? Shoot, I knew this one was going to be a problem. Let me just move it there. Okay, so C27H44O12 minus my water. Okay, and that gives me my final formula of C27H38O9. So again, I added up all of my monomers, subtracted out the water, 1 molecule of water for each bond. There is my final formula. Okay, and 3H2O would be a product there. So there's the final formulas. I outlined them in purple. So your basic strategy, always add up the formulas for each individual monomer, then subtract out 1 molecule of water for each bond that you make.